Okay, to start with, we're discussing about a file system administration. We discussed about how to create a partition, format a partition, mount a partition, and how to access the partition. But yesterday I said that like we have physical disk restrictions on the partitions. See this example for figure here. I have one figure. I have one hard disk by name /SDA, whose size is 60 GB. Now in this hard disk, I have created few partitions like SDA 1, 2, 3, 4. So for this total how much for SDA1, what the size I've allocated as 10 GB. So into this SDA1, I can write 10 GB of data, not more than that. That is a restriction. So if you want to write more than 10 GB, that's not possible. Okay. So if you want to overcome these physical disk restrictions over this on this physical partitions or physical disk here, then we need to go with one more concept that is called as LVM. We call it as a logical volume manager. So what is LVM, logical volume manager? I will discuss a part. 1 minute. Let me power on my multi machine. Okay. Let us discuss about that LVM over here. So what advantages and disadvantages, we'll check it out. So first let me take one disk here. And this is one disk. Assume that the disk is like SDA. Then Control C to now see this as an example. I will take these three disks. The first one is disk is SDA. Assume that whose size is 10 GB, and this one is SDB, whose size is 10 GB, and this is SDC, whose size is 10 GB. Okay, so I have three physical disks. What are three physical disks are? SDA, B, and C. And the size of each physical disk is 10 GB. So on this physical disk, we have physical disk restriction. The restriction is the maximum capacity of a data you can write into the disk is the size of the disk. If the size of a disk is 10 GB, we can write only 10 GB of data. Suppose if you have 100 GB hard disk, you can write 100 GB. Now, I want to overcome these physical disk restrictions. So if you want to overcome these physical disk restrictions here, what we have to do is we need to convert that physical disk into physical volume. Now, we have a volume manager concept in Linux. When you bring the physical disk under control of volume manager, that is called as physical volume. So the point is, on this physical volume, we can overcome the physical disk restrictions. Here. Now you can see I have three disks, three physical volumes. Now, what can you do with this physical volume is I can club these physical volumes together and I can create a volume group. Now see here, volume group. Now, if I'm adding three disks, for example, see this one here, this is first disk, SDA, right? And from this SDA, if I add it to this one here, that is volume group. Now in this volume group, I have one disk now right now. As from figure representation, you can see I have SDA disk. That physical disk I converted into physical volume, and that physical volume I added to the volume group. Now this volume group size, what the size of my volume group size is 10 GB. Why? Because to this volume group, as of now, I have added only one disk. Now, if I take a second disk here, I have converted it to physical volume, And then what I'll do, I will add that physical volume to the volume group. Now see, my volume group has two disks now. What the two disks are? SDA and SDB. SDA size is 10 GB and SDB size is 10 GB. Now what the size of my volume group is? My volume group size is 20 GB. In a similar way, I can have this third disk. So SDC, a physical volume, and then I can add that physical volume to this volume group. So when I add this volume group here, now my physical volume group have three disks. What are three disks are? SDA, second one is SDB, third one is SDC, and what my total capacity is 30 gig. So the thing is, what we are trying to do, we are trying to club individual disks into a particular group here. When you club this individual disk into a particular group, that is called as volume group. That is called as volume group. Now, what the size of my volume group is? My volume group size is 30 GB. The size of the volume group depends upon the size of the physical disks that are added to the volume group. Now, from this volume group, what can you do? I can create a logical volume. I can create a logical volume. From this volume group, I can create a logical volume like this one here. Right? I can create a logical volume, and the logical volume size can be the logical volume size, minimum size can be like a 4 MB, and we can increase the size up to 30 GB. The size of a logical volume can be 4 MB, and we can increase it up to 30 GB like this. Previously, we have SDA. On this SDA, what the maximum capacity you can write? The maximum capacity you can write is only 10 GB. But now, when you club all these physical disks and create a volume group, what my volume group size is 30 GB. Into this 30 GB, I can create a logical volume, and the logical volume size can be the size of a volume group. For example, in future, 30 GB is not sufficient. If you want one more disk, if you want some more capacity, what can do? I can connect a disk, right? I can connect. I can 1 minute. I can convert that physical disk into physical volume, right? And then I can connect this physical volume to the volume group. I can convert that physical volume to this volume group. So when I add this to the volume group here, for example, this disk size is, for example, 10 GB. Now what happens? The next disk will be like a SDD. So it will be added, and we can add up to this one, like the size can be like 40 GB like this. Okay, this is the scenario. Initially, we have physical disk. On the physical disk, we have physical disk restrictions. To overcome these physical disk restrictions, we'll convert that physical disk into physical volume. On the physical volume, the physical disk restrictions are eliminated. Why? Because we can connect that physical volume to the volume group. We can connect the physical volume to the volume group. So what a volume group is? Volume group is nothing but a collection of physical volumes. Collection of physical volumes. Now let few important points. To create a volume group, we require minimum one physical volume. To create a volume group, we require minimum one physical volume. And maximum, how many physical volumes can you connect to the volume group? We can connect up to a maximum of 256 physical volumes to the volume group. As of now, from the figure here, we can see I have added only four physical volumes. But like this, how many can you add? You can add up to 256 physical volumes. To create a volume group, we require one physical volume, and we can connect up to a maximum of 256 physical volumes to a volume group. The size of a volume group depends upon the size of the physical volume. The size of a volume group depends upon the size of a physical volume. The least size of the volume group is the least size of the physical volume that is connected to the volume group. The least size of the volume group is the least size of physical volume that is connected to the volume group. And from this volume group, what can do? We can create a logical volumes. From this volume group, we can create a logical volumes. How many logical volumes can you create? How many logical volumes can you create here? So the thing is, from this volume group, we can create a logical volume. we can create up to 256 logical volumes again. We can create 256 logical volumes for one volume group. The minimum size of the volume group is 4 MB. Actually, here from my volume group size is 40 GB, but the minimum size of volume group, logical volume you can create is 4 MB. And from this 4 MB, we can increase the logical volume. Up to what size we can increase that logical volume? We can increase that logical volume up to 40 GB. Means the size of the volume group. In future, if you want to, if your volume group is not sufficient here, you can keep on adding a physical volumes to this one. Okay. Now into this volume, logical volume, when you write the data, where the data is saved, from this logical volume, the data comes to this volume group. From this volume group goes to physical volumes, and from the physical volume it goes to physical disks. This is actual scenario. So in file system, the previous concept what we discussed, we are writing the data into one disk. But now what we are trying to do, we are planning to write the data into multiple disks. We are planning to write the data into multiple disks. So it increases the span, it increases the expansion of your physical disk here. So if you want to increase the span of your disk here, so we can use this concept over like this. Right? Hope it should be clear. Now, yesterday's session here, then in yesterday's session itself here, we have created this physical disk like this, SDB, CD, we created 3 physical disks here. So those physical disks, first we need to convert it to physical volume, then volume group, and create a logical volume. Let us see how to do this one. And for this implementation, actually, how many steps do you have? So first one is, we should have a physical, first thing is, identify physical disks. First step will be identify the physical disk here. Second thing is convert a physical disk to physical volume. Convert the physical disk into physical volume. And third one is create a volume group. Create a volume group. And then the fourth step will be create a LVM, logical volume. And the fifth step will be format LVM. And the sixth step will be like a mount LVM. These things. Okay. Now one more thing. I'd like to share one important point here. From this volume group, I say that if you want to create a logical volume, the minimum size of a logical volume can be 4 MB. Why 4 MB? Why not it is from 1 MB? The thing is, when you connect a physical volume to the volume group, this physical volume is divided into small parts called as physical extent. Yeah. See this, when we connect a physical volume to volume group, so what happens? And the physical volume is divided into small parts called physical extents. So when you connect a physical volume to the volume group, the physical volume is divided into small parts called physical extents. Okay, and by default, the size of the physical extent, is 4 MB. So the default size of physical extent is 4 MB. So the minimum logical volume you can create is 4 MB. The maximum can be the size of a volume group. Right? Hope it should be clear. Let us do some practical representation on this. So it's somewhat slow. Yeah, got it now. Now, so for the first step is to recognize the disk. So what a command to recognize the disk? Fdisk specify find disk specify. So we have this disk SDA. This is my OS disk. Let us not consider this. We'll leave this and use some other disks. Okay. So what other disk do you have? I have SDB here, right? Whose size is 10 GB. Then I have SDC 10 GB, SDD 10 GB. These physical disk. So on this physical disk, we have physical disk restrictions. Okay. And if you want to overcome these physical disk restrictions here, what we have to do, we need to convert this physical disk into physical volumes. And to convert this physical disk into physical volumes here. So what a command that I use to convert a physical disk into physical volume? Especially when you go for this command pvs, it will display the physical volumes, or pv display. When you go for pv display, it displays the physical volumes. Does it displaying any physical volumes? No, it's not displaying any physical volumes. Okay, now let us create pv create is a command to create a physical volume. Pv create /dev/sdb. I'm using sdb disk here initially. So at present, I'm creating only one physical volume. So what the physical volume is? SDB. Can you see? Physical volume SDB is successfully created. When you go for PVS, you can see I have one disk /dev/sdb, that is LVM2. The physical size is 10 GB. So if you want to have a clear clarification, we go with this command pv display. So when you go for pv display, you can see what the physical volume name is SDB. What the size of the physical volume is 10 GB. Okay, so you can see the physical extent allocated size is not showing anything. So what these values will be shown only when you add the physical volume to the volume group. Okay. So now, as of now, we have created only one physical volume. Let us try to create other physical volumes also here. So fdisk specify nav. So we have SDB, that is already physical volume now. We have two more, SDC and SDT. So okay. So I have two other physical disks, SDC and SDD. I'm trying to convert that into physical volumes. So you can use like this pv create. You can specify multiple disks at a time, SDC and SDD. Enter. Now see, successfully created. So PVS. How many physical volumes are there? Yeah, 3 physical volumes.
Excuse me,
SDB.
sir.
Yeah.
Hello.
Yes.
Your
Yes.
screen
Yes.
is not.
Unable to see screen. Yeah, please share the screen.
Is it visible now?
Yeah, okay
Yes.
now, sir.
Yeah.
Thank you.
Fine. So initially, I have used this command to create a physical volume. That is, it to convert only one disk here. Then later, by using PV display, we have verified. Now I executed one more command here, like a PV create a /dev/sdc and SDD. So I'm converting these two disks, SDC and SDD, into physical volume. So what are they? SDC and SDD both are now physical volumes. Now you can see the physical volume size is 10 GB, 10 GB, and 10 GB. Okay. Now from these physical volumes, what we have to do? We need to create a volume group. We need to create a volume group. So if you want to find any volume groups here, we can go with VGS. You can see there are no volume groups found. So VG create volume group name, for example, my data VG, and to this /dev/sdb/dev/sd sdc. See one thing, I'm creating a volume group and my volume group name is my data VG. I have 3 disks, but I'm adding only 2. What are the 2? Those 2 are SDB and SDC. Okay, now you can see VGS. Previously, when I extracted VGS, what I said that no volume groups found. But now when you go with VGS here, I have one volume group, my data VG. It has 2 physical volumes, and what the size is 19.99 GB. Now let me show you something clearly. PV display. So you can see now here, PV display, the first disk SDB. So what is SDB is one of the disk. It is added to the volume group. My volume group name is my data VG, whose size is 10 GB, whose physical extent size is 4 MB. Now what the thing is, this 10 GB is divided by 4 MB. 10 GB divided by 4 MB. So the total physical extents we got is 2559. So these are total physical extents that are allocated to this disk, and these are the number of physical extents free. If you want to create a logical volume, we require at least one physical extent to be free. Okay, now see SDB and SDC, right? And we have this physical volume SGD, but this SGD I have not added here. So I have added only the B and C. I have not added D till now. Okay, that's why physical extents, total physical extents is not showing anything. If you want to extend VG, you can see it here. When you go for VGS, I have VG, data VG, it consists of only 2 physical volumes. Otherwise, if you go for this command here, VG display, it shows you a clear clarification. Data V, the format is LVM2. How many areas are there? 2. And how many physical extents? 2. Actual physical extents? 2. What the volume size is? This much. Total physical extent size is this much. How many physical extents are there? 518. Now, if you want to add one more disk, we have one more thing. So VG extend. VG extend. What is my volume group name is? My data VG and /dev/sdt. I've added, sorry, B and C. Now I'm adding D. Yes, you can see my data VG is successfully extended. What are the VG display? How many physical extents are there previously? We have 2. What the size is? Approximately 20 GB. Now let us verify it again. VG display. You can see now here the volume group size is 30 GB. Physical extent size is 4 MB. So these are the total physical extents, and this is the size of my volume group. So this is how you can create a volume group. Now from this volume group, what can we do? We can create a logical volume. We can create a logical volume. So let us see how to create a logical volume. So LV create, very simple. PV create to create a physical volume, VG create is to create a logical volume, and LV create is used to create a logical volume. LV create -L, and I want to give it as like a 1000, and then -N, my vol1, and what my volume group name is, my data VG. See, LV create -L stands for length here. So I want to give it a length of like 1000 MB. -N means new logical volume. My logical volume is my vol1, and data VG created from this volume group. Can you see? A logical volume my vol1 is created. If you verify LVS, you can see my vol is a volume name, my data VG is a volume group name, and these are the attributes. And what the size is 1000 MB, right? Where 1024 MB is 1 GB. Now let us check it out here. VG display. Sorry, we should go for like LV display. So when you go for LV display, so this is the entire logical volume part. This part you need to remember. /dev / my data VG / my wall 1. This is my logical volume name, my wall, and this is my volume group name, right? And this is, we have read permissions, everything. So how many logical extensions are enabled? 250. Why? Because 250 into 4, that becomes 1000 MB. So once if you go for VG display, from there we can even cross verify that these are allocated. Actually, we have this many here. These are still free, and these many are allocated. Okay. Now, as per the steps provided here, we have identified the disk. We converted the physical disk into physical volume. We have created a volume group. We have created a LVM. Now, what the next step will be? We need to format the LVM and need to mount it. So, if you want to format the LVM, we need to remember the LVM name. What the LVM path is: /dev / volume group name and / logical volume. Now, see, let me format mkfs.ext4 and that's it. So this is the command which I used to format it here, right? It is formatted. Now you can see mkdir / my wall, and let me mount it here. Mount. So what the logical volume name is? It is logical volume and / my wall. Now dspace-h. Now see this. But this SDA1 partition, the size is 20 GB. The mount point is this one. Now this is my volume group /dev / my data VG, in which I created one volume, logical volume, right? My wall. What the size is 985 MB, 18 MB is the use, and this is the mount point. Now, how much data can you write into this one logical volume? We can write approximately like 1000 MB. But the requester said that this is approximately 1 GB. 1 GB is not sufficient. I have a 5 GB of data. What can you do in these scenarios? So in these scenarios, what can we do is we can increase this logical volume. The physical disk has restrictions. We cannot increase them, but whereas we can increase this logical volume. So how to increase? Let me show you here. Like LV extend -L plus I want to increase it 5 GB size. So extend with 5 GB and the logical volume name. What the name is /data /dev / my data VG / my wall 1. Enter. Can you see? Now logical volume extended, right? To what size? 5.98 GB, the 6 GB, right? This is only extended, but the file system is not updated. So we need to execute this command here, size to fs, and the logical volume name. This command is mandatory. Now see, previously it was 1 MB, 1 GB. Now what the size is? 5.9 GB. Now, if you want to still increase, yes, we can still increase. Like I would like to increase it 15 GB. Yes. Then after that, resize it. dspace-h. Now what the size is? 20 GB. Can you still increase? Yes, we can still increase. How much size can you increase? Depends upon the size of your volume group. In your volume group, the total size this one here. How much is free? We still have 9 GB. We can increase 9 GB. Let me try to increase with 10 GB now here. Like for example, here 10 GB. So what is saying that insufficient free space. So if you have insufficient free space, now what can I do? I can request my administrator to add one more disk here. So if I have administrator, if I add one more disk here, we can like this. What we'll do, he will add that physical disk. So hard disk, add hard disk. Next, I want 10 GB hard disk. Here 10 GB is fine for me. Next, finish. Okay. Now, when you connect a new disk here, when you go for fd space -L, so you have up to SDD. The new disk is not recognized. So what a command that we have to run? Rescan. First scan the system for the new disks. So once a disk is scanned, let me go in verify now. Fd space -L. You can see, oh yeah, I have this SDD 10 GB. Let us verify whether this SDG is a physical disk or a physical volume. SDD. These are physical volumes. What are they? B, C, D. This is not a physical volume. Yes. Now I can convert that into physical volume. So what the command will be? pv create /dev/SDE. Successfully created. Then when you go for this VGS here, so what my VGS, this is my VG volume group name. Water size is 30 GB. I would like to add one more disk, that is SDD here. So what the command will be? VG extend. VG extend. What my volume group name is? My data VG. My data VG. And what the new physical disk is /dev/SDE. See, extended. So what the size is now? The free space is 19 GB. Okay. Now previously, when I tried to extend this by using this command here, what is said? It is failed. But now, will it be successful? Yes, it is successful. Then resize it. See, /h. Now see, it's 31 GB. So like this, if you want to overcome physical disk restrictions of the partitions, then you can use this concept called LVM, Logical Volume Manager. But now even this logical volume manager has some disadvantages. What are the disadvantages are? For example, in this logical volumes, like the thing is, suppose if we have written the data, all these are the part of volume group. What a volume group is? My data VG. Fine. Suppose suddenly if this disk is crashed, /dev/SDC is crashed, then what happens? The entire logical volume will be lost. Okay. We don't have fault tolerance here. If something has gone bad, that's it. We cannot recover. So I want to overcome this also. Suppose if something is gone, I want the recovery to be occur. I want fault tolerance. So if you want to have a fault tolerance here on these physical disks, what to do is we need to enable RAID configurations. When you enable a RAID configurations, then what happens? If any one disk is crashed, we can overcome this. Let me point two disadvantages here. On this physical disk, when you write some data, the read rate speed is normal. I want to increase the read rate speed. This is first point. Second point is, if any one of the disk is crashed, the entire data is lost. I want to recover that. Okay. I want my read rate speed to be faster, and I want the fault tolerance. So if you want the read rate to be faster and want the fault tolerance to be enabled here, then on this disk, we need to enable RAID configurations. We call it as redundant array of independent disk. Redundant array of independent disk. We can have two types of RAIDs here. One is called software RAID and hardware RAID. Tomorrow I'll be showing you that software RAID and hardware RAID. Once you get through all the concepts, then I can teach you about the hardware RAIDs. Okay. Now we have constructed step by step. Let us remove all these things one by one. So you want to remove, first unmount the logical volume. Okay. Then LVS. Then remove the logical volume. like LV remove my wall 1. Saying that 1 minute. LV remove slash dev slash my data VG, my data VG slash my my wall 1. Yes, right. LVS, logical volume is removed. VGS, VG remove slash dev slash my data VG. Yes, remove. Now you can see no volume groups, no logical volumes, but we have physical volumes. So what the command will be? PV remove slash dev slash STG. Otherwise, we can see SGC slash dev slash SGD and slash dev slash SGE. Successfully wipe. Now see this PVS. No physical volumes, no logical volumes, no volume groups. This is how we can create the things. This is about the LVM. This is basic stuff. If you dig into this one, we have more in-depth concept in this one. Right? We'll end this for today here. Now, any queries and questions, please let me know.